Right, welcome to our videos again. Today we're going to be finding gradients. Remember, I've told you in previous videos that when you're trying to find the gradient of a line, you're basically differentiating when you're trying to find the gradient of a line, you're basically differentiating the equation of that line or the function. Okay. So in this first case here, I've got a straight line which is given by y equals to 2x plus 1, and this being the x-axis and that being the y-axis. Now, if it's a straight line like this, we've noticed that the gradient is always that number there. Okay, so this gradient would be 2. In other words, the steepness of this line is the same. It's going to be 2. So at this point, the steepness is the same. The steepness is the same all over. That's why the gradient is a constant, is a number, right? So here, for the first diagram, for the first line, the gradient is at 2. And this 2 is the same. In other words, the steepness of this line, because the straight line, the steepness is just constant. It doesn't change at all. Okay, so for straight line, the gradient function, the gradient is always a constant, a number like this. However, when you have curves like this, the steepness keep changing. The gradient will depend on what point you are in the line. For example, when I'm this amount point 0, 0, the origin here, you can see that the gradient of this line becomes flat. The line becomes flat here. So the gradient here is going to be 0. Now, if you look at this other side, you can see that this line is rising. So the gradient again is positive because the line is rising. So it's positive. However, on this other side, starting from this side, you can see that the line is falling down, which means that the gradient is going to be negative. So for a curve, the gradient will always change at all times. Now, the value of that gradient is going to depend on what point you are in. So say, for example, at that point there. So this value of gradient will depend on this point. Now, we can look at this point as coordinate, right? So we can call it, let's say, for example, B, X being A there, and Y being B there, okay? So the gradient at this point is going to depend on what X is, right, particularly, okay? Or if you want to say what A and B is, or what A and Y, what X and Y are, okay? So when you have a curve, the gradient is changing all the time. But when you have a line, the gradient is constant, it's just basically fixed. Now, for that reason, when we're dealing with curves, we normally talk about gradient function, not just gradient. For example, when the line I'm talking about or the curve I'm talking about is y equals x squared, then if I differentiate that, the y dx, that's going to give me 2 times 1, which is 2x, right? The 2 take away 1 from that, and that becomes 1. So here, I want you to notice that this gradient here is not fixed because it says it's 2 times x. In other words, it's going to depend on what x is then, right? So for this curve here, to find what the gradient is at any particular time, I will need to do 2 times what x is there. So at this point here, I will need to do 2 times a because x is a there, okay? And maybe somewhere here, I'm going to do 2 times what x is here. Maybe x, let's pretend x is 3 here, okay? So you're going to see that the gradient is going to be negative because if you do 2 times negative 3, you're going to have negative. So that's going to be negative there, okay? This side, let's pretend that x is 5 there. Let's put 5 there. Then you can see that the gradient is going to be positive 10. So 2 times 5. So when it comes to curve, we talk about gradient functions because you still have x there, which means that the gradient depends on what x is, okay? Right, so example 1 says a curve has the equation y 3x squared minus 5x plus 4. Find the gradient of the curve at the point where x is 2. Now we are so interested in x because when you differentiate this, you're going to end up with x still being there, not y. So therefore, the exact value of the gradient will depend on what x is at that particular point in time. Okay, so what I could do is to try and sketch, just trying to sketch this. This is a quadratic curve, so I will pretend that maybe it's something like this. Just pretend. Okay, so that is going to be the that's going to be the function f of x or y. Okay, so let's just call it f of x. Now remember, f of x is the same as y, and f of x is 3x squared minus 5x plus 4 in our case here. So what I want to do now, first of all, I need to find the derivative. I must find the gradient function by doing dy dx. Okay, that's going to be 2 times 3, which is 6, and the power, that 2 goes down by 1. Then here, I'm going to have minus 5. Okay, because this x has 1 times 5 is 5, and the 1 which was at the top here, becomes 0. So x to the power of 0 is always 1. 5 times 1 is this 5 here. We've always said that the constant numbers like this, when you differentiate them, they just disappear. So now we are ending up with what we call the gradient function for this curve here. Now, so this is dy dx. This is basically what the gradient is, but exactly what the gradient is going to be is going to depend on what point we're talking about. Okay. Now let's pretend that we are talking about the gradient at this point here, where x is 0. Okay. Or let's just pick where x is 2, for example. Let's just say where x is 2 there. So we're talking about this line here. So here, what's the gradient going to be there? Now to do that, you're going to sub in 2 in this function here. So you're going to say that when x is equals to 2, the gradient is going to be this 6 times by 2, because this is 6 times x, so 6 times by 2 take away 5. So we're going to have 12 take away 5, which is going to be 7. Okay. So when x is 2, the gradient is going to be 7. In other words, it's going to be a positive rising line. Now, this curve might not represent this function because I only sketched it. But all I wanted you to understand is basically the gradient of a curve will depend on what value x is. If I pick a different value, say for example, I pick another point. Let's say for example, I pick this point where x could be something like, say for example, 5. Then the gradient is going to be different. The gradient is going to be 6 times by 5, right? 6 times 5, take away 5, which is going to be what? 25. Okay. So the gradient will always change. Okay. Now what I want you to do is to I want to explain something again that I've not explained before you try these questions. Now, usually the gradient of a line, of a curve, is the same as the gradient of a tangent that is drawn there. Now, the tangent is basically a straight line that is drawn touching a curve at a particular point. So the tangent to this line will be that line there. So the tangent to this curve here at this particular point would be the line that just touches it like that. This is a tangent. So usually at this particular point, if you look at it, the gradient of this line here, of this curve at this particular point here, is the same as the gradient of this tangent here. Okay. So the gradient of a curve at a particular point is the same as the gradient of the tangent drawn passing there. So that's what I want you to notice. But in terms of working out, the idea is very, very the same. Okay. Right. So I would like to try question A for you very quickly. It says, find the gradient of the graph of y equals x squared when x equals to 5 as the first thing, and then when x equals to -2. The first thing you need to differentiate, so you do dy dx function, differentiate that. That's going to be 2 times 1 is 2, and then x at the back there like that. So that's the first thing. The second thing, all we need to do is to now find what the gradient is exactly when x is at 0.5, when the curve is at 0.5, when the point is at 5 of the x, as the first thing. So we now say that when x is 5, the gradient becomes 2 times by 5, which is going to be 10. Okay. So when x is 5, the gradient, you can say dy dx. Okay. When x is 5, the gradient dy dx is going to be 2 times 5, because x is 5 equals 10. Okay. Now, however, when x is different, say for example, when x is -2, then the gradient is going to be 2 times -2, because that's what it says. It is a gradient function that you have to use. So that's going to be -4. It basically means that when x is negative, right, this curve is falling down. And when x is positive, then it's a rising curve. Now, let me just sketch that quickly for you. Now, remember, the function y equals x squared is something you should be able to do by yourself. Now, y equals x squared is always a quadratic function that passes through the region and goes up like that if I sketch it, okay? All right, so this should be basically a nice curve. I'm just doing it using my free hand. So what we are saying is this, that when x is negative here, when x is -2 at this particular point here, you can see that this gradient here, if I draw a tangent there, you can see that is a falling line. It's basically negative, okay? That's why when I sub in -2 here, I end up with negative. It shows that the line is basically falling left to right, okay? So the gradient negative. However, when x is positive, and x is positive this end here, okay? So let's say that's that point there. And if I try to draw a gradient there, I mean tangent there, let's just try drawing it. You know, quite hard to draw using freehand, using this software. But if I just draw it there, let me just take that off again. Just gonna draw it again. Okay, so if I do it like that, so if I take this point here, right, and I try to draw a straight line passing through that point, okay, now that tangent here will have a gradient same as the gradient of the curve at that particular point. So now, how am I going to get the gradient? I'm going to use 5 as x, and I'm going to side between there. If you do that, you get up with 10. Now, it means that the gradient here is positive. The line is rising. So if I just draw another parallel to that, the line is rising on this end. That's why the gradient is going to be positive on that end. Okay. Now, having understood that, I would like you now to pause the video and try question 1A all the way to F, please. Okay, hope you tried them. So quickly, I'm just going to do question E for you before I show you the answers. Just going to do question E for you before I show the answers. Okay. So the first thing you need to do is to differentiate. So do dy dx. That's going to be dy dx. Now 6, remember, is a constant, so that becomes 0. And then for this part, we do 2 times a half. So 2 times a half is 1. So I've got negative, remember, 1. And then x, this power goes down by 1. So it's just basically going to be x. So let me repeat that. The 6 is a constant. If I differentiate that, it disappears. Then I take this power times by half. 2 times a half becomes 1, and there's negative in front. And then this 2 becomes 1 on the power here. So it's just basically minus 1x, which if you simplify, it just becomes minus x. Okay. Now, when x is 4, the gradient dy dx becomes negative 4 because x is 4. Just sub it in. Okay. Now, when x is 3, then dy dx, dy over dx is going to be negative of negative 3. Okay, so it's going to be negative of negative 3 because we say it's negative x. It's negative of what x is. So it's negative of this negative 3 here. Now, negative over negative becomes positive. Okay, so that's how to do this kind of questions. So if you want to pause the video quickly, and if you just want to mark where, please. So pause the video and just mark where quickly. Okay, hope you done well on that. So that's going to be the end of our first session, of our session on this part.